Hey, welcome everyone. In this video we are going to talk about solution to the second problem of linked list round 2 in Hyderabad Best Coder contest. Now this problem had very low success rate because 25 people attempted it and 3 were able to solve it completely. That means all the test cases were passing for those 3 people. So let's go ahead and solve this challenge. So now if we try to read the problem statement, it talks about some annual fest of BVRIT Hyderabad in which students have come from various colleges, and kind of input we are getting is it's telling us how many students have come to the fest, which is 3, and after that other lines are telling who was the student and what was the name of the college. So Shabnam from Vasavi is the first student who came to attend the BVRIT Hyderabad fest. Then Aditya came from CBIT, then Ashwarya came from Vasavi. Now if this input is given, we have to produce a sample output where we have to sort the students in such a way that first the students from the college which are alphabetically in first in dictionary, we have to put them first. Like if we sort their college names alphabetically, we know CBIT will come first, Vasavi will come second. So first we arrange Aditya CBIT moves up before Shabnam and Shabnam moves down. So after we do sorting based on the college names, second level of sorting has to be done based on the student name, and that should happen within the same college students. So we should be sorting Shabnam and Ashwarya based on the name of the student. So Ashwarya will come first and then the Shabnam will come. So input format was simple. Line 1 will contain an integer n representing count of students that we have seen, 3. The next n lines contain 2 space separated words, name of the student, name of the college, where ns is name of the student, name of the college, and some constraints are given to us which say name of student will be 2 to 20 character long and name of the college can be from 2 to 10 characters long. Now this is very important to keep these constraints in mind and declare the variables accordingly, because many test cases are designed in such a way that we will be given a student name which will be 20 characters long. Same way we will be given a college name which is 10 characters long. So our test cases should pass for all those inputs. Now again, this is a variation. Like this problem has multiple possible solutions, but one that we are going to talk about is a smarter solution where we will not create the linked list and sort. We will in fact initially create a sorted linked list. Like if you remember the previous problem we talked about, we were inserting in already sorted order. So two approaches that we are talking about. One approach is insert as the first step, insert all the names in the linked list, and second, do the sort. This is one approach of solving the problem. A lot of people have tried that and they were able to successfully do that, but the smarter way is we simply do sorted insert. So at the time of insertion itself, keep sorting them so that you don't have to do that as a separate step. So we are going to discuss this algorithm for solving this problem. So let's go down and switch to the side-by-side view, and let's take a look at what is given to us. So we are given a structure which has name of student, name of college, and the thing to notice here is name of student is not a character array, because if it was a character array it would have been given like char name of student 21. That is a character array, but this declaration is ns is a pointer, and this pointer, since it is not initialized, it will be pointing to any garbage memory address. That means we cannot use it directly. Before using it, we have to allocate it. We have to say ns is equal to malloc, and we have to allocate 21 bytes if we are storing the 20 characters in it. After allocating, we should start using it. So this was the catch in this problem, that first we should be allocating space and then we should be putting any value there. A lot of people who would have tried it directly using without allocating the memory, they will face the segmentation fault, which is the crash, because we are trying to access a memory which does not belong to us. That's a garbage address. Now if we take a look at main is simply calling our function read input and create list. That means we should be writing the logic that reads this input and creates the linked list. So let's go ahead here. So if we are reading the input, the first line to read is n. So again, similar to previous problem, ampersand n, we declare n. Now after we have read n, there is a string. Since the next line is a string, we should be cautious that we have to remove or we have to match the /n, which is after 3. Okay, so once we have done this, again we will write a for loop or while loop, because we have to read n number of lines. Since in previous video of the previous problem I used the for loop, here I'll show another variation. So here we will use while loop. While n minus minus is not 0, we continue to read the values. So this is the loop I'm putting. Okay, so this is shorthand way, most widely used by people in programming contests to save some time. So if n is 3, it will say while 3, and after that it will make the value of n 2. Then it will come for 2, it will run. It will come for 1, it will run. Then n becomes 0, it will not run. Okay, so let's get started by reading two names each. Now when we are reading two names, we'll say scanf %s and put a /n, and we have to read name of the student first, then name of the college. So n student, n of college. These are two variables I'm using. So let's declare these two variables here. Char name of student, we will declare that to be 21. 20 for the name and 1 character for new line. Sorry, for null character. Same way we declare n of college, and that we will declare of 11 character, 1 for the null character, 10 for the name. Okay, now this will give us the student name and college name. Now using that, we will create a node and we will do the insertion. So what we will do is, like a previous problem, we'll declare the head of linked list, we'll call it null, and we will say update the head by calling insert sorted in list. And what we will give is, we'll give the head, we will give n student, name of the student first, and we will give name of the college second. And we will ask this function, can you go ahead and insert this node which contains this student name, this college name into the linked list, and insert in such a way that it is sorted. And after the loop is over, we have inserted everything, we will return head from this function. So hope this is clear. We are reading n. After that we are reading each line, and whatever data we are reading, we are asking insertion function to insert in the linked list. Now our goal is to write this insertion function. So let's make a copy of this, put it here. Return type is node star. Input parameter, first one is node star head, second is char and student. Here ideally we can change the value also. We can say this is small ns, this is char and c, name of the college, and we have to write body of this function. So let's go back and put a curly brace here, curly brace here. Now again, to do the insertion in the linked list, first we should create node. After creating the node, we should say insert in beginning if list is null, or in sorted order, or if it comes before the first node. Then we have to handle the case of insert in middle. Then we have to handle the case of insert in end, and in all these cases we have to return the head. Now if you remember, this function is similar to what we did in the first problem, with only difference is there the comparison was between one term, and here the comparison is between, first we have to compare the name of college and then we have to compare the name of student. So little modification over previous code. So what I'll do is, I'll get the previous code here and then we will start modifying that. So I click the name of the contest. We go to the first problem submission that I did. We go to my submissions, because here I'll get my code that I submitted for this problem. So here what I will do is, I'll copy the code we wrote for insert sorted. and we will come back to Princy sort, and what we will do is we will paste the code here and we will modify the previous code. So see, previously also we did allocate node, so we will need this code as it is. Then we had to put the name in the node, so let me do Control X, move that here. Or rather than writing these many lines here, we can also create a new function, node star create node. So create a node, in that you put name, and we put name of the college, name of the student. So all this code that we are writing, we can move inside that function, so that here our algorithm remains simple. And typically when we split our code in terms of functions, the solving the problem becomes easy. So now in create node, we will see we are allocating the node first, so we allocated node. Second, what we will do is we will put the name in the node. So first we should put name of student. So name of student, here we can see it is ns. We will say n of ns is input parameter ns, we are copying into node of ns. Same way we will copy paste this line. We will say name of college that we get as input parameter, we are copying into n of name of college. So that way we have put the values of these two members of the structure. Now we should initialize next. So let's go ahead and say n of next equals null, because whenever we are creating the node for the first time, we initialize it with null next, and we return n, and n sorry, n is the next node, new node that we have just now created. Now since that we have written as a separate function, we can call this function with various inputs. So let's call that from here. We say node star n equals, we call this function create node, and we pass that ns and we pass that nc. So we are saying if we pass you name of student and name of college, this function we are calling, we say can you create a node and return that to us. Once we get that node, our job remains to fix that node in the right place. Okay, so previously we wrote all that code within the same function. This time we made one change. We have made create node as a separate function. Now let's handle the first case. If the linked list is empty, what we do? We simply return n, because in empty linked list case, n is the new linked list. N is the new head of the linked list. Second, previously we were inserting in the beginning if the name was smaller than the head name. Now here also we will say insert in the beginning case is this. So insert in beginning here will happen only in cases, let's say, let's take an example. Aishwarya is the student name and she is from Vasavi. So this is our first node, let's say. Now what happens is Aditya comes, and let's say Aditya we have to insert, and Aditya, and let's say Aditya is also from Vasavi. So what we will do is first we will compare Vasavi with Vasavi. That way we know, okay, Aditya should come first, because college wise it's equal, so Aditya can be first or last. College wise comparison doesn't tell whether it should come first or last. So college wise we are easily sure like it should come first. Now Aditya and Aishwarya, if we compare, because they belong to the same college, Aditya should be inserted before Aishwarya. Since comparison is involved of two values, we can write a separate function for that, because it is Aditya with Vasavi, and otherwise we could have Aditya with CBIT also. Now if we compare CBIT with Vasavi, direct answer is because this is smaller than this, we don't need to compare the name, directly do the insertion. So we need to make a decision, and that decision will be something like this. If should insert before, we are asking a function, should we insert name of student, name of college before the given node, which is head node. So that is the question we are asking to that function. If that function says true, what we will do is we will insert the current node, which is n, before head. So this is clear. We are writing this function. So let's go here and we say bool. Now if we want to use bool in C, we have to do hash include std bool.h. So we say bool should insert before, let's give the name of the student, name of the college, and both these are arrays, and we give the head. So we are asking, can we insert ns nc before head? Now as we said, only case in which we will insert before is, first we compare, okay, first we check if strcmp head of, because the first node head, if the name of college, which is nc, the currently that we are inserting, if that is less than head of nc, okay, here we should write node star. If the college we are inserting is less than the head of nc college, then we are sure we are inserting before head. So this case, if you see, it is case like if cbit we are inserting and in head Vasavi is there. So since cbit is in nc, Vasavi is there in head, cbit is less than Vasavi, so we are returning true, that here decision is clear. Another case where we will insert in the beginning is, let's say Vasavi has come as college name, Vasavi is already there in the head, but name of the student is Aditya and head had Shabnam there. So if the college matches, the comparison we are doing is between the names. If college itself tells us the decision, then we can return true from here. So let's go and add this code. If strcmp nc head of nc, if they both are equal, it will return 0. Now if it returns 0, we should do the name comparison. So we should go inside this if condition and we say if strcmp, now we are saying if name of the student is less than name available in head, we can say return true, because in this case also we can insert before the head. Otherwise, in all other cases we will return false. Now other cases are, if Vasavi was there and after Vasavi, let's say Vignan comes, Vignan University, then we are inserting after this. So first case for Vignan will not be true. It will not be true here also because they are not equal. It will go here and say false. Whenever it is false, we move forward. So this function was the key in this complete problem. Once this function is figured out, then after that writing code is easy. Now here we are checking if we should insert ns nc before head, then we are saying n of next is head. Since we do not have a previous, we are returning n. So we say insert before head, which means n ka next will become head and n is in the beginning. Now n is new head. So insertion in beginning is done. Now we come to insert in middle. Like the previous case, we take node star c equals to head, and we take star p, which will be previous. So initially we can make it null. Say while c is not equal to null, we keep on going, and here I should correct the spelling mistake. Okay, if c is not null, every time we'll move c next. Now what we will do is, and also we will keep track of p is equal to c. So this is like keep previous node, and this is move c to next. Now every time we will be checking if should insert before, because that function we have written, we can call that every time. We are asking, should we insert ns and nc before c? If that function says true, then only we will insert, otherwise we will keep moving all of them forward. So if the answer comes true that we should insert it before, then we know simply if we are inserting before C, then first we should say, so kind of we are at this situation, C is here, P is here, and we have a node N that we are trying to insert. So if this C says that insert before C is true, then our N should fit in between P and C. So what we should do is P next should point to N, N next should point to C, and that way we will say insertion is done. And we should be returning the original head wherever we came from, because in this case we are not inserting in the beginning. So with that in mind, let's write that into code. Yeah. So if we should insert before C, so we should say P next equals N, because this is the previous next. Then N next should be C. So previous is connected to N, N is connected to C, and insertion is done. And ideally from here we can return the original head. So this is insertion in the middle. If we find node before which we should insert our data, we are done. Now insertion in end only case is if C becomes null, that is where when we typically will come out, we'll say P of next equals N, because if C is null, we are doubly sure that previous is pointing to the last node next is equal to N, and ultimately here also we return head. So ideally here we do not need to make this check, because we know it will come out of the loop, so C will always be null. So even if I remove this check, then also the code is fine. We are simply saying previous next is equal to N. And now we have written the entire logic. Let's remove the code we copied from the previous problem. So this is the code that I copied from previous problem. So we have done the sorted insert. After we do the sorted insert, the list is completely made. Then we return that list to head, and after that we were calling Princy sort. So this was given to confuse people that they have to create the list and then they have to sort. Now since we have already created a sorted list, there is no work required here. So what I will do is this function, I will make it dummy function, and we will say in Princy sort whatever head we are getting, we are returning that back, because in our case we have made sure linked list is already sorted. So let's go and run this code. Okay, my test case failed. Let's figure out why the test case is failing. There has to be some problem, and this problem is segmentation fault, which means I have made some mistake somewhere in this code. Let's figure out the mistake, and mistake is very silly, and that silly mistake is, initially I pointed out, NS is not an array, so it does not have any space allocated, and we are trying to copy NS directly into N of NS. So since this NS does not have space allocated, copying any string into a random memory location will cause the segmentation fault. So what we should have done to avoid this is N of NS is equal to malloc size of char into how many characters we are storing. That is what we have to tell. Now how many characters are needed to store NS into N of NS? Now NS, if NS is CBIT, sorry, name of the student, if that is Aditya, or say Adi, Adi has only 3 characters. So 3 characters if we are putting in NS, we should also account for null character, so we should be allocating 4 characters ideally. Now when we get a string like this, and if we call string length, it gives length by excluding the null character, so we will get the length of 3. So let's do it that way. So we are allocating space for characters, size of char, and how many characters we need is string length of name of student plus 1. So this will ensure that we have sufficient space allocated. Same copy paste we will do for name of college, NC, and this is also NC plus 1. So after doing this allocation, if we copy the string into NS and NC, that will be perfectly fine. So let's make that change and let's go ahead and run our code. And this time we observe the test case passed because no segmentation fault. We are allocating the memory and we are writing into that. So let's go ahead and submit our code. Now in order to avoid seeing this confirmation, we can disable it. We can say do not ask me again, and we can say submit. Now this will try to run our code against all the test cases, and once they pass, the status will be accepted. You have solved the problem. So this is the solution to the second problem. Hope things were clear and it helps you to learn from the mistakes that were made at the time of contest. So thank you for watching this. In next tutorial, in the next video, we'll talk about solving the next problem, which is Gabbar is back, and then we'll move to Moonrisers Hyderabad, and that's where we will close this series. Thanks for watching. Have fun. Happy coding.